Hello, and welcome to Literary Notes, a podcast by the Washington Talking Book and Braille Library. I'm your producer, Nathan Ureta, and this episode is a look back into the library archives. Physicist and science writer Micho Kaku visited the Washington Talking Book and Braille Library in June of 2008. He spoke with library volunteer Jeff Cavanaugh about his book Physics of the Impossible, a scientific exploration into the world of phasers, force fields, teleportation, and time travel. They talk about teleportation, invisibility, and other ideas that were once far-fetched, but thanks to science, might be closer than we think. Here's their conversation.
With me in studio today is author Micho Kaku. His new book is The Physics of the Impossible. It's out in bookstores everywhere, and as a matter of fact, as he tells me just before we started recording, it's number 12 on the New York Times bestseller list, so it's definitely going to be easy to find. And we welcome Mr. Kaku to the studio. Good afternoon.
Glad to be on.
Thank you very much for taking time to join us today. Before we talk about the book, because this is your first time here, tell us a little bit about yourself.
Well, when I was a child, I had two role models, two heroes. First was Albert Einstein. Everyone was talking about the great scientist who had just died, and everyone was saying that he had his unfinished greatest work that was to be his final testament, but he never finished it. It was to be the theory of everything, the theory of the universe. So I said to myself, wow, I want to work on that theory. And I do. That's what I do for a living. That's my day job. Mm-hmm. But then I had a second role model. I used to watch Flash Gordon on TV. And I love Flash Gordon. But I realized very early in life that I didn't have blonde hair. I didn't have muscles. But the figure of Dr. Zarkov, that fascinated me. Here was a scientist, no blonde hair, no muscles, but with the sheer force of intellect, just by thinking and having knowledge, he could build starships, ray guns, he could go to the stars. And I said to myself, that's for me. Well, my day job today is working on Einstein's unified field theory. I'm the co-founder of string field theory, one of the main branches of string theory, which we think is the theory of everything. But I still remember my childhood days of watching Flash Gordon. Anyway, then when I was in high school, I realized that my parents were very poor. In fact, my parents were locked up in a concentration camp during World War II in California from 1942 to 1946. So I realized that my parents were very poor. And I realized that if I'm going to do anything to realize my dream, I'm going to have to do it myself. So in high school, I went to my mom and I said, Mom, I'm going to build an atom smasher, a 2.3 million electron volt betatron part accelerator in the garage. And my mom said, sure, why not? And don't forget to take out the garbage. So I took out the garbage, went to Westinghouse, got 400 pounds of transformer steel, 22 miles of copper wire, and I built an atom smasher. The magnetic field was 10,000 Gauss. It would pull the fillings out of your teeth if you got too close to my atom smasher. I finally plugged it in. It consumed 6 kilowatts of power, all the power in the house. I heard this pop, pop, pop sound as I blew out every single fuse and circuit breaker in the house. The house would be plunged in darkness. And my poor mom would say, how come I don't have a son who plays baseball? Maybe if I buy him a basketball. And for God's sake, why can't he find a nice Japanese girlfriend? I mean, why does he build these machines? Mm-hmm. Well, the reason why I mentioned this is because I went to the National Science Fair. Edward Teller was there. He was the father of the hydrogen bomb. He immediately knew what I was doing. I didn't have to explain to him what I was doing. Bingo, he said, I'm going to give you a scholarship. So I got a 4-year scholarship to Harvard. And that changed my life. Because then I could start to work on Einstein's unified field theory, and I could begin to dream about physics of the impossible.
When did you decide to start writing for the popular media as far as...
Well, I'm a research physicist, and most physicists snicker, laugh, and their eyes roll up when they find out that somebody's writing for the public. You know, there's sort of like a snobbery that, you're writing for the public. I mean, those boobs out there. But then something happened. In 1993, our machine was canceled, the Super Collider. The biggest machine of science ever conceived of by the human mind was canceled.
And this was being built in...
Dallas, Texas.
Right.
outside Dallas. Now the Europeans are doing it. European Union picked up the torch. They're going to turn on their machine in 2 months, in May of this year, outside Geneva, Switzerland.
Right.
But our machine was canceled. And the day of the hearing, one congressman asked a physicist, what will we find with this $11 billion machine? Will we find God with this machine? If so, I will vote for it. Well, the poor physicist didn't know what to say. So he said, we're going to find the Higgs boson, another particle. Well, you can imagine all the jaws hit the floor. $11 billion for another darn subatomic particle. They canceled the machine. And ever since then, we physicists have replayed that scene in our mind over and over and over again. How should we have answered that question? Will we find God with your machine? Well, I would have answered it this way. I would have said God by whatever signs or symbols you ascribe to the deity. This machine will take us as close as humanly possible to his or her greatest creation, Genesis. This is a Genesis machine. This machine will unravel the secret of everything there is. That's our machine, and it was canceled. And now it's going to be debuted in Europe. The European Union is now picking up the torch. So that's why I wrote this book, to convince taxpayers to keep on funding basic research.
There are others like you who've written for the popular media. What sets you apart from them?
Well, Stephen Hawking, I think, set the pace. He showed that a physics book can sell. And it did. He outsold all the Hollywood movie stars put together. Something like 15 million copies of his book were sold. And this book, Physics of the Impossible, like you mentioned, hit the New York Times bestseller list. So who would have thought that a book with the name physics in it would be so popular? But there's a hunger out there. People want to know, what is the brief history of time? People want to know what is possible and not possible when you see the movies. When you see Star Wars, Terminator, Close Encounters of the Third Kind, you wonder, are these possible or not? And there's no good book to explain it. Well, that's this book. This book explains whether or not invisibility, teleportation, ray guns, telepathy, psychokinesis, time travel, whether any of these things are possible or not.
So you break these various ideas down into different classes of probability. Class 1 are things that are very likely going to happen in the near future. Class 2 being things that could possibly happen given centuries of research. And Class 3, things that are more likely than not never going to be
downright impossible, right? Yeah. Class 1 impossibilities include most of what you see in the movies. Telepathy, psychokinesis, robots, artificial intelligence, ray guns, starships, antimatter engines, invisibility, teleportation. Believe it or not, they are engineering problems. The basic physics is there. It's just a question of throwing money at it. Now, time travel is in a different category. It's not going to be realized in the coming decades or maybe even centuries. We're talking about manipulating the power of a black hole, or the power of a star. Any advanced civilization that can play with stars, like Star Trek, for example, could conceivably build a time machine and bend time into a pretzel. But it's not for us. It's not for us.
Well, let's relatively speaking, let's take this back a little bit and consider all of the things that we take for granted now that were considered impossible. And I mean not just sort of not likely, but completely flat out impossible by the best minds in science at the time.
Okay, well, take a look at invisibility. As late as 2 years ago, I used to teach to my optics class that invisibility was impossible. Every optics book on the earth says that it's impossible. And 2 years ago, we did it. 2 years ago at Duke University for microwave radiation, they showed that if you bathe an object with microwave radiation, the microwaves can bend around the object, reform at the other end, so that the object becomes invisible. Think of a boulder in a river. The water wraps around the boulder, reforms at the other end, and if you're downstream of the boulder, you don't know there's a boulder upstream. That was done 2 years ago at Duke University, and just a few months ago, as the book was going to press, Caltech, scientists in Germany and Iowa, showed that red light and green light can also bend in this way. So within this decade, I suspect that we'll get the first object, a cup or a book, shine one color at it like red light, and bingo, make it disappear. After that, we'll make the three primary colors, red, green, and blue, disappear. And then after that, Harry Potter, watch out, invisibility cloaks. Who would have thought?
Well, I'm brought to mind, of course, by the recent death of Arthur C. Clarke and all the various news coverage that got, and his credit, the credit that he was given for the invention, quote unquote, of telecommunication satellites, which back when he came up with that idea, we hadn't even launched any sort of object other than 4th of July, rockets. There was nothing in science at that time to even think that that was possible, and yet here is someone coming up with that and it coming true in the most wildly successful fashion.
Right, or take a look at Jules Verne. In 1860, he writes a novel, never published, called Paris in 1960.
Oh, yes.
That was discovered by accident by his descendant, and there was Jules Verne talking about fax machines, talking about something that looked like an internet, talking about automobiles, talking about glass skyscrapers, which were impossible in 1860. And there it is in Jules Verne's work. Now, today, we physicists think that we can also make predictions like that because we do have a good grasp of atomic physics, the quantum theory. We do have a good grasp of Einstein's theory of relativity. And so we do think that the predictions we make today are going to be realized in the future.
I was caught by chapter 10, the quotes that precede the chapter, which really kind of sum up the whole predicting the future technology and science-wise. Isaac Asimov was quoted, "The most exciting phrase to hear in science, the one that heralds new discoveries, is not eureka," translated as "I found it," but that's funny. Meaning serendipity, finding things that you weren't even looking for.
That's right.
To turn out to be the breakthroughs.
Yeah. Look at teleportation, for example, right? Scientists have looked at zapping an object across the room, having it disappear, reappear someplace else, and we would all say, ha, impossible. But then by accident, by looking at atomic physics, we realize that atoms can do this. Atoms can disappear, reappear someplace else. So we thought to ourselves, aha, maybe we should do it with atoms first rather than Captain Kirk and a starship. Well, 10 years ago, we zapped the first particle of light, a photon, across a room. The world's record now is 100 miles. From one Canary Island to another Canary Island, we can teleport a photon. The next step is the space shuttle. Believe it or not, we're going to set up an experiment in the space shuttle and teleport a photon from the Earth to the space shuttle. We can teleport atoms, too. Cesium atoms, beryllium atoms have been teleported. Maybe a water molecule within a decade. After that, DNA. Can you imagine? We're going to teleport DNA in the future, maybe even a virus. And Captain Kirk is going to have to wait, though. I mean, you're talking about teleporting a human with 50 trillion cells is a lot of work.
But that just sounds like it's a matter of time and money.
It's an engineering problem. And remember that Star Trek takes place in the 23rd century. So many of the science fiction devices found in that TV program may be realizable by the 23rd century.
And stop and think how many of them already are.
Look at cell phones.
The flip phone.
Everybody has a cell phone. And there was a science fiction TV program in the 60s predicting that we'll all have cell phones. And here we are today with cell phone technology.
The second quote from Mark Twain, "If the man doesn't believe as we do, we say he's a crank, and that settles it." I mean, it does nowadays because we can't burn him. How often have you or your colleagues been lambasted, either in the popular press or by others in your field, for thinking too far ahead?
Well, take a look at black holes. Black holes were actually first worked out in the 1920s, but it was so fantastic, a star that is so massive that even light itself cannot escape, that you just had to laugh. And in 1939, believe it or not, even Einstein wrote a paper stating that black holes are a solution of his equations, but they probably cannot form naturally by any known natural phenomena. Well, now the Hubble Space Telescope has photographed thousands of these black holes in space. We think that's what holds the Milky Way galaxy together in some sense. The moon goes around the Earth goes around the sun, but what does the sun go around? It goes around a black hole at the center of the Milky Way galaxy that weighs about 2 to 3 million times the mass of our sun. So sometimes the outrageous becomes true. Arthur C. Clarke once said, quote, "Any sufficiently advanced technology is indistinguishable from magic." And that's what this book is about. It's about the magic that is indistinguishable from technology.
The third one, I think, is probably the most telling. You can recognize a pioneer by the arrows in his back. And that was a quote from Beverly Rubik. What made you include that?
Because so many times scientists snicker and laugh and their eyes roll up when they hear things like UFOs. Now, think about it. These scientists say that UFOs are not possible because the distance between stars is too great. It would take hundreds of years to go between stars. But that assumes that an alien civilization is maybe 100 years more advanced than us. But look at the universe. The universe is billions of years old. Very likely, if we ever meet a civilization in space, they're going to be thousands, millions of years ahead of us. In which case, going between stars is not such a big deal to them. So that's why we have to open our eyes to the laws of physics and not be prejudiced into thinking that civilizations are only 100 years ahead of us, when they could be equally 1,000,000 years ahead of us.
Growing up, besides Einstein and Flash Gordon, once you started to realize that science was your calling, were there other science fictional things that caught your eye and sort of fired your imagination?
Yeah, my favorite science fiction author was Isaac Asimov. And even as a kid, I read his Foundation series, and that really blew my mind away. Usually science fiction is shoot 'em up. Oh, the aliens are there. Bang, 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 you're dead, right? That's what science fiction is all about usually. Here was the Foundation series talking about civilization maybe 50,000 years into the future, when we've colonized most of the Milky Way galaxy. We're so advanced that we even forgot where Earth is located. Nobody knows where Earth is located anymore. And that really opened my eyes to the possibilities of advanced civilizations. You know, forget Flash Gordon. Flash Gordon is maybe 100 years more advanced than us. But what about 1,000 years more advanced? And then you begin to think, well, what's the difference between engineering and physics? Engineering is what's possible. You just have to throw money at it. Physics tells you what is and is not physically possible according to laws. So I said to myself, let's write a book like Physics of the Impossible, where we talk about the difference between something that is engineeringly difficult, like teleportation or telepathy, versus things that are really, really, really impossible, like perpetual motion machines. That violates the laws of physics to get something for nothing, even though the Wall Street Journal often calls me on the phone and says, we have another inventor making millions of dollars pushing his perpetual motion machine. Should investors invest in him? And I quote the words of P.T. Barnum, quote, "There's a sucker born every minute."
Or as Robert Heinlein had said, there ain't no such thing as a free lunch.
Yeah.
There's just no way to get the something for nothing.
Right. But everything else short of that, like telepathy and time travel, interdimensional travel, things short of that may actually be possible. And that's why I wrote the book, to tell people that it's not so far-fetched. Like, for example, reading minds. We say that, oh, that's impossible because how can you possibly read somebody's thoughts? But recently, scientists took a stroke victim who is paralyzed, cannot communicate with anybody, it's like a vegetable, put a chip in his brain, connected the chip to a laptop, and had the person move the cursor of the computer screen. That person at Brown University can now answer emails and play video games and write emails and surf the web by sheer thought, by thinking about it. In the future, we'll hook up something to the brain directly, and even average people will be able to surf the web simply by an attachment directly to their brain. This is coming.
I always joke every time I have to buy a new cell phone that they're getting smaller and smaller. And now we have the little Bluetooth dealie that just hooks to your ear, and you have the phone on your belt. How soon do you think it's going to be before we're able to actually implant a device in our heads?
We can do it now. However, it is a little clunky. The device is about 2 inches by 2 inches, and it hooks up to a small attachment on your waist, which then hooks to your laptop. It's clunky because it's experimental, and it's only about 5 years old. You can imagine, with our ability to pack 100 million transistors on your thumb, that in the future we'll be able to miniaturize it so that it's not even visible and have it connect to the brain, and you can surf the web by thinking about it.
Still looking at a screen, though, or is this something that's going to be internally perceived?
Perhaps both. These people, of course, have to look at a PC screen. The studies are being done at Brown University. In the future, maybe we'll hook it directly to the optic nerve. You realize that already we can take a video camera and hook it up to the optic nerve. The number of pixels is rather small. We're only talking about a few hundred pixels. But in the future, we may be able to, there's no reason why we can't hook up a few million pixels to the optic nerve and have people see via a TV camera.
One of your chapters here also deals with, we talked about teleportation, phasers, ray guns, and the like. There was a science fiction story in one of the magazines dealing with some sort of ray gun that's sort of an anti-personnel, non-lethal crowd dispersal type
Stun
thing.
gun.
A stun gun, or what it wound up being was some sort of high-end radio wave generator that excited nerve endings to make
it's a microwave gun. It excites the skin and makes the skin feel very irritated.
Right, and now it's an actual device that the Army's
for riot
deploying.
control.
Yeah,
right.
But that's an old school ray gun,
right?
Which we now have.
Right.
I really found that just amazing.
Yeah. And a real ray gun that can blast through steel, we actually have lasers that can go right through concrete and steel. The problem is a portable power pack.
Right.
We have not yet created a battery that you can put in your hand that can deliver enough energy to go through a brick wall. However, the Death Star of Star Trek, Star Wars, that can destroy an entire planet, that's actually possible. And in fact, in outer space, I make a prediction that one day we'll find a dying star that's about to explode, and any empire could point it at the Earth and conceivably blow the Earth up. Just on the internet right now, we found such a star. It's called WR104. We've been tracking it for the last few weeks. It's pointed directly at us. And one day it will blow up. We know it will blow up. How much energy, we don't know. But it is pointed at us, and we physicists are monitoring it very carefully. It could be a doomsday Death Star, or it could be a dud. We don't know for sure.
In what way do you mean pointed at us?
It's a double star system. So think of a dog chasing its tail. So two stars chasing its tail. So we know the axis. We know the axis. And energy goes through the North Pole, as we now know. Of the star. So we know where the North Pole is pointed. Otherwise, of course, it's just a star sitting there. We don't know where north and south is. We know where the North Pole is because it's spinning, and we can see it. It's on the internet, in fact. You just type WR104, and there it is. Gorgeous photographs, and you're staring down the gun barrel. You're staring down the gun barrel of an unstable star. It is 8,000 light years away. Too far for a garden variety supernova to kill us. But if it turns into a gamma ray burster, it can definitely fry the Earth. And it would fry the Earth, and you wouldn't even know you're being fried until it's too late.
Now, that's at light speed, so you and I have 1,000 years to wait before.
Yeah, if it had already blown up 8,000 years ago, then we could be fried tomorrow and not even know it. There's no warning.
That's true.
No warning.
We have no way to know that it's gone.
That's right. No way of knowing what's gone. And it travels at the speed of light. So you have no warning until it fries you.
That's not making me feel very warm and fuzzy.
Right.
Thank you.
However, I just talked to an astronomer the other day, and he thought it's going to be a dud. His calculation shows that it's not going to pack the wallop of a gamma ray burster. Let's hope he's right.
Let's see. Chapter 13, Parallel Universes. You quote a couple of science fiction, let's see, the TV show Sliders, Robert Heinlein's Number of the Beast. Where do you see that going? And of course, you have string theory as part of that, which is your specialty.
It used to be that parallel universes was the stuff of Twilight Zone and science fiction, but now it's front and center in the middle of physics. And for example, we now believe that our universe is a bubble of some sort, like a soap bubble. It's expanding rapidly. That gives us the expanding universe. We live on the skin of the bubble, but now we believe there are other bubbles out there. This is called the multiverse idea. And one of my friends at MIT may eventually win the Nobel Prize for laying the foundations of this theory. And it says that there could be big bangs happening all the time. Our universe was created in a cosmic explosion 13.7 billion years ago. But we now believe in continual genesis, continual creation, universes popping into existence all the time, almost like a soap bubble budding or sprouting a baby soap bubble. And we think we can prove this theory too. The next generation of space satellites are gravity wave detectors, and they'll pick up the shock wave. The embers of the original explosion that are still echoing through our universe will pick that up. Now, today we have baby pictures of the Big Bang. We've actually photographed it. It's in the microwave region, but we have microwave satellites. The radiation has been spreading out for 13.7 billion years, and we photographed it. It looks like an explosion, just like we thought. But the new generation of satellites will pick up the explosion at the instant of time, and then we may even find evidence of an umbilical cord connecting our infant universe to a parent universe. That's speculation, of course, but NASA is already putting millions of dollars to build this next generation of detectors which may detect radiation from the pre-Big Bang era.
You mentioned, as we discussed the different classes of impossibilities and their likelihood of being solved, and the class 3, the most unlikely of them, one of them you mentioned was the perpetual motion machine, which you indicated by the laws of physics is just simply not possible in any possible way. The other one that you mentioned in Chapter 15 is precognition. Why is that a class 3?
Because every time we have cause and effect, we see that one precedes the other. Now, time travel, of course, does pose some questions. We do think that time travel may be possible centuries into the future, but we think we can restore cause and effect even with time travel. For example, Einstein said that time is like a river that speeds up and slows down, and we measure it with our GPS satellites every day, the fact that time can speed up and slow down. But the new wrinkle is that the river of time may have whirlpools by which you can go backwards in time, or the river of time forks into two rivers. Therefore, what does causality mean if you can go backwards in time and your teenage mother meets you and falls in love with you? If your teenage mother falls in love with you, how can you be born? Because she just spurned your future father. Or worse, if you go backwards in time and kill your parents before you're born, how can you be born? How is cause and effect going to be reestablished? The way to reestablish it is with the forking of the river of time. If the river of time forks into two rivers and you go back to save Abraham Lincoln, you've really saved somebody else's Abraham Lincoln. Another universe has split off, and in that universe, you save somebody who really does look like Abraham Lincoln, genetically the same, with all the same memories, but he's not your Abraham Lincoln. Your Abraham Lincoln died back in the 1860s. So we do think that causality can be restored even if you have time travel. So the laws of physics, we think, have causality built into it. You cannot establish a telephone system to the future or a telephone system to the past.
But the multiple branching of the time stream, if you will, you think allows you to go back to a certain cusp moment and observe which way things are going to fall, which way the stream goes, or is it all always there and you just have to find it?
Well, again, we think we can go back and observe where time is going to split into two times, but you cannot alter your own past. That is, your mother gave birth to you. That cannot be changed, even though the woman you just dated looks like your mother as a teenage girl, but she's not really your mother as a teenage girl.
Sounds like you're paraphrasing Back to the Future, Michael J. Fox.
That's right.
Right. Okay. I'm afraid we've actually gone right through a half an hour very, very quickly, and I wish we had some more time to spend, but I thank you very much for coming in and speaking to us. Again, the book is Physics of the Impossible. The author is Micho Kaku. It's a very informative and entertaining read. I highly recommend that you pick it up. Thank you again very much for your time.
My pleasure.
Michio Kaku's book, Physics of the Impossible, a scientific exploration into the world of phasers, force fields, teleportation, and time travel, is in the catalog of the Washington Talking Book and Braille Library. It's available as an audiobook with the class ID DB067077. If you have any questions or comments about the library, or to see if you're qualified for our services, visit WTBBL.org or call us Monday through Friday from 8:30 a.m. to 5:30 p.m. at 206-615-0400 or toll free at 800-542-0866. Literary Notes is a production of the Washington Talking Book and Braille Library, based in Seattle, Washington. This episode's interview was conducted by former library volunteer Jeff Cavanaugh. I'm your producer, Nathan Ureta. Thanks for listening.